we're at another AF Mixer. So tonight we've got a few things on the agenda, one of which is actually, in fact, Peter's talk on phase-locked loops, I believe. Something tells me that he already did something on that, of course, but perhaps he's got something else to talk to us about that, because he still has that on tonight's topic on the SOAREX schedule that's posted. So I don't know if that's a typo or what, but we also have Charlie that you're going to be talking about thermal impedance, I believe, with regard to, specifically to heat sinks. Anyway, looking forward to that. I see we've already had some AI, in quotation marks, discussions. So I think that is a current topic that's on a lot of people's minds. So Peter and I thought it would be interesting to discuss that a little bit amongst ourselves and see where people's minds are at and share information that we have, what we've experienced and all that. So we'll talk about that. And then a little recap of a little build session that three of us participated in, Hassan, Michael, and myself, this past Sunday. So, and that with a brief roundtable, I guess we'll probably wrap up the evening. So,
can I put a bag over my head now, Eric?
Sure, absolutely. That's okay. I mean, you know what? If depending on which one of you e-transfers money before we get to that topic, you know, either board can be, you know, yours, Michael. So we'll see. Let the bidding begin. So anyway, yeah, well, yeah, we did have fun, and we had some learnings on that day. So happy to share that with the group as well. So I think we will probably get started with your presentation, Charles, since you're on the screen and Peter is not. I have a feeling that Peter maybe did not have much to say, but we will see when he returns. Is everything okay with Peter? Did anyone see him actually get out of his chair, or did he like slide downwards, clutching his chest or anything like that? No? Heaven forbid. He's all good? All right. Well, hopefully he returns. He was on the screen at some point, I presume, since I did not get here till 7:30. So, but anyway. All right. So, Charlie, if you'd like to take the helm.
Sure.
Oh, by the way, sorry. Just before I almost forgot. Please note that all of our meetings are recorded and made available to the public for viewing on our YouTube channel. By participating in this meeting, it is understood that you have accepted the terms. Okay, now you can go ahead, Charlie.
Do the terms include AI training?
AI training. I'm going to feed that into DeepSeek, you know, once I load it onto one of my systems and see what it thinks. To embellish this statement.
Where did it go? Sorry, guys, just getting started here. All right.
Yeah, there we go. Looks good.
Okay. You'll have to interrupt me if you need to talk, because my main screen is now covered with the chart. So this evening I was going to talk a little bit about thermal management and basically how to pick a heat sink and why you would choose that particular one. There's been a lot of chatter about heat sinks in the last while, and some discussion around fans and, you know, where fans should be mounted and so on and so forth. So I thought I would dust off this presentation and add an extra couple of charts to it, and we could talk about it a bit this evening. So when it comes to heat sinks, there are a lot of choices out there. They come in various sizes, various mountings, various designs, flat plates, round pins, you know, just vanes and so on and so forth. All of these different methodologies are trying to get the most surface area in a given volume of space, and that's surface area, air contact on the surface is basically what transfers heat out of that heat sink. So how do you go about choosing it? Where do you start? Well, there's a model for that, and this is a pretty standard thermal impedance model. It starts with the device we're trying to protect, the actual junction inside the chip. If you go dig through its data sheet, it will tell you what the thermal resistance is from the junction to the case of that device. Most devices are encased in plastic these days. Some have a metal tab on the back if they're expected to dissipate a bunch of heat. But you'll find in the spec sheet just what that thermal resistance is. The case then gets connected to a heat sink through a thermal paste of some sort, whether it be a thermal grease, and it has a specific degree C per watt from the case to the paste, and another degree C per watt from the paste to the heatsink. And then, of course, there's a thermal resistance from the heatsink itself to the ambient air. It's worth noting that when you put numbers and all of this and put it together, this is a steady state model. Short-term or transient excursions don't apply. And I mentioned an example here, you might have a device that's got a specified junction temperature of max 110 degrees C, but it will happily withstand 300 degrees C for maybe up to 10 seconds while you're soldering it. The temperature that junction gets to directly impacts the device's life. So if you run it at close to that max of 110 in this particular case, it's going to have a lifetime that's on the order of months to perhaps years. If you were to run it at considerably less than that temperature, it could have a lifetime of in the span of years to decades. And in fact, the way chips are tested for their mean time between failure, or how long they'll live, is by putting them in a higher temperature environment, which accelerates the life. And there's actually a very specific model of how many degrees you raise it up, how many factor of what gets applied to the number of hours or days that the device is being tested. So just to talk about this model a bit more, I thought I'd take an example, our old friend, the IRF 510, which many of us have played with many times. I dug out its data sheet, and in its data sheet, it has a maximum junction temperature of 175 degrees C. It has a junction to case thermal resistance of 3.5 degrees C per watt. I know that case to a heatsink, if they're both flat and the grease has been applied between them, it's typically 0.5 degree C per watt. Our unknown question mark here is, what is our heatsink to ambient thermal impedance? And so you'd add all these up to come up with a junction to ambient temperature, right? So we take our thermal resistances of 3.5 and the 0.5 and the not sure what. Then we take our worst case ambient temperature, sorry, you add up those degrees per watt and then multiply the number of watts you're going to dissipate. Take a look at what the worst case ambient temperature is for your device. Usually that's 50 degrees, but it could be 30 in reality for our stuff. So we take that, whatever the ambient temperature is, plus the thermal resistance, which is called theta. And as long as you're much, much less than 175 degrees C, you're good to go. So in this example, so we've got 10 watts in that IRF 510. Well, the junction to case is going to be 10 times the 3.5 degrees C per watt, so 35 degrees. The case to the heat sink is going to add another 5 degrees. We'll say our worst case ambient is 50. So our 50 plus 35 plus 5 takes us at 90 degrees, and our maximum is 175. So the heat sink's got to provide 175 minus 90, or 85 degrees C of cooling at 10 watts dissipation, or 8.5 degrees C per watt. So off you go, hunt through the data sheets and find one that that will give you a number that's better than 8.5. You know, getting something in the order of 1 would be fantastic. And that's basically how you choose that heatsink. That, coupled with, of course, it needs to fit in the area on your board where you need it. You need to be able to mount it in some way, and you need to be able to get some airflow over the top of it, whether that is just convection, or whether you actually put a fan in place. Depends on the overall thermal design that you're working with. Some interesting data I discovered when I was poking at this is that the thermal conductivity, you know, has gases are terrible. Liquids I would have thought were very good, but they're actually not terribly good conductors. They kind of fit in the same category as some insulators. Plastics and oxides are a little better. When it comes to alloys, things like nickel and aluminum is close to the alloy end of things. And probably one of the better metals you can get is up around silver. Copper's quite good as well. Coming back to that model I was talking about with thermal impedance, this really is a standard thermal modeling way of looking at things. So, you know, the electrical equivalent is you've got a current flowing through a resistor, you've got a voltage on one end of it and a voltage at the other end of it, and that current is, you know, V1 minus V2 over the resistance. When it comes to thermal, exactly the same thing. You've got a temperature at one end of it, a temperature at the other end of that thermal resistance, represented by theta, and Q is the equivalent of the current, or the thermal flow going through it. At the bottom, I've put the formula for theta. Well, I was mentioning conduction of different kinds of metals in that chart originally. Here's some of the conductivity for various metals. The aluminum ones seem to range between 138 for stampings up to maybe 209 for extrusions. But there are some stampings even with aluminum where you can get up to 220. This is a specific heat sink type, and this is the specific alloy, aluminum alloy, that's being used. But you'll note the copper ones here do much better. Like the copper ones are nearly double the conductivity of even the best aluminum ones. So when you go to buy a heat sink, this is the kind of thing you're going to see in terms of the data sheet. So there'll be this graph is for natural convection, and it's basically, you know, degrees rise per watt dissipated. This one is for forced convection. So you've got a fan involved, and with feet per minute across the top, and then degrees of cooling down the side. What most data sheets tend to do is they'll put both of those graphs on the same chart, just to save space in the overall data sheet. That's really the only reason for doing it. This example I got from a data sheet is 579802 heatsink. So it has both of these on here, and you can basically just pick your operating area on it. I'm not going to attempt to read all of this stuff on here. I chopped this out of the data sheet, but if anyone's looking at the recording later, they can kind of read through this stuff. If I zoom into that one graph, sorry it's so fuzzy, but my I lost some resolution when I was zooming it. This line is the natural convection line, and if you choose your operating point here, this only goes up to 5 watts, but you can scale this. So if you've got, let's say, 2 watts, you'll be looking at for natural convection, you'll have about a 55-degree rise on this small little heatsink. This one is one of the ones that clips on to a TO220 package with a little, looks like a letter C from the top with some little fins on it. So it's not terribly great at getting rid of heat, but it's certainly better than nothing at all. So here's a picture of a larger heatsink, and this is a thermal image of it. This is how it's actually oriented. And so with the device that's dissipating the energy bolted right on here, you can see this is going to be the hottest part of the heatsink, is where it's attached, exactly what you'd expect. It gets conducted away from there, but you'll note the top part of this is warmer than the bottom part. It's actually quite cool down here at the very bottom of these fins. And as the natural convection airflow flows up through here, it's less and less able to absorb heat as the air gets up here, and actually you'll find that there isn't as much airflow up there as you would actually expect. So here's a sort of the picture I just showed you, but a blow up of the space between a couple of fins here, and what you can see is it's as the cool air enters in and starts heading up, the airflow kind of slows down, and whether it's leaking out over the ends or exactly what's happening, it's not nearly as effective at keeping the temperature down as you get further up. This is where, having something like a fan to try and add a bit more pressure in there to push this deeper blue further up the stack and possibly even up as high as the top. This I thought was an interesting one too. This is one where there's a fan blowing across one of those ones that I showed you early on that's a whole collection of pins. Just zip back up here for a sec. Yeah, it would be like this general purpose one up here, close to the center, which is a whole collection of pins on a back plate. You can see that the cool air blowing in one side, flowing from left to right, the airflow slows down significantly as you get to the right here. There's just resistance to the flow of air, and of course these things end up being hotter on this side than on the other side. And part of that is due to boundary layers. So as the air is flowing through, there's the velocity changes as it approaches the barrier, the blades of the heatsink. And if you look at this lower one here, you can see that this thermal boundary layer that forms actually extends, in the case of a serrated fin heatsink, well above it, and there's really not much airflow taking place over here at all. So the air is just not contacting, so you're not getting much benefit of the fan blowing across. In this particular case, you'd want to turn that so that you're going down the grooves rather than across it. So I stole information from a couple of papers that I thought were quite good. The best one I've seen is this one, which takes you to a PDF file that talks about this thermal management stuff in a lot more detail than I've gone into here this evening. The second one, this URL will take you to the data sheet for Heatsinks, and a very good one that goes through all of the details of how they do the calculations, how you figure out the exact details of the area that you require, and so on. And you know, how many cubic feet per minute you need blowing across there. Is there back pressure in the room, and so on and so forth. I think that's it. I thought I had one more in here, but apparently I have not. So we'll call it at that. Do we have any questions? Let me see if I can take that down. Stop sharing.
So that was pretty much a tie in hand raising there, Charlie. So we'll do it alphabetically. I'll say Howard. Thank you for joining us. Hopefully your audio is with us.
Yeah, no, I got that sorted out. So,
oh, and video. Look at that.
Woohoo!
like a game show, who can raise their hand the first there? So,
yeah.
I just had a question. When the data that's provided for the heat sinks, do like the thermal image that you had in one of your slides, do they assume that the device that generates the heat is going to be in the center, or are there some based on the conductivity of the material where it doesn't matter, or it has to be off center, or is it always supposed to be in the middle?
Typically, the center is the place to go, because you get rid of heat through a number of methods, right? It gets conducted away, it gets radiated. There's several methods where the heat disappears. So you take advantage of you take the best advantage of the area of the heat sink by putting your device in the middle.
Right.
The other thing too is that you know, like if you go and look at that catalog of heat sinks, it gives you all the correct information of, you know, how many degrees C per watt, and then you can do your thermal calculation very easily. The problem is, for guys like us, we almost never go by a heat sink. We'll go scrounge one that we found from an old piece of equipment, or and then you're sitting there, well, what the heck is the degrees C per watt of this 1970s transmitter that I scooped a heatsink off of? And the answer is you can measure it, right? So it will have a rise above ambient per watt. So you dissipate 10 watts in it, let's say. Take 10 watts worth of resistors on the back with some thermal grease, clip them on, put 10 watts on the thing, leave it sit for 10 or 15 minutes, and then measure the temperature of the heat sink, and that will tell you its degree C rise.
That sounds good. Thanks, Charles.
Okay.
Okay, yes, Eric just had to step away for a minute, so I'm up next.
You are.
Thanks for that, Charlie. I always knew there was more to heat sinks and all that kind of stuff. I just never ventured in there, left it as a rabbit hole for another day. So thank you for opening that up. I had two questions, and you just answered one, and that was, how do you estimate that whole pile of heat sinks I got in there? I never thought that when I ordered them, I should have got a data sheet with them. Of course, where I ordered them from, there probably was no data sheet anyway. But the other one I thought it came to mind was when you were talking about the temperature that your chip is operating at and the detrimental effects that it has at the higher temperatures. What about the opposite end of the scale? Like, like if your chips are operating down in the, they're half frozen.
Generally speaking, that's not a problem. Heat's the killer when it comes to integrated circuits. So you can generally cool them off quite a long ways. Now, some devices don't like the cold. The LEDs, for instance, the current finds different paths, and they'll either not be bright or not even be on at all when they get super cold. So there's often a lower temperature spec, but hey, if the lower temperature spec for a device is say minus 20°C, and you could run it at minus 20°C all the time, junction temperature, man, that thing would live for 1,000 years.
So that's like your equipment that's on top of those mountains in the Yukon. It'll last forever.
Well, a lot of that stuff has been up there 25 or 30 years without a visit, right?
Thanks, Charlie. Appreciate it.
Okay, I don't see any other hands up. I had a couple questions. Would thermal imaging of the heat sinks provide any useful information when, designing or choosing or selecting between a few if you had some choice? Would you think that would be a useful tool, or just the mathematics?
Well, so when I said I want to find out, if I wanted to find out what the degree C per watt of an unknown heat sink was, I would apply some energy to it, and then I would measure the temperature. Thermal imaging would be one way of measuring the temperature, right?
Right. Okay. And this is not directly related to the heat sinks, but just your comment about on the data sheets, the fact that some components can withstand, a threefold higher temperature than the steady state amount. Is that something that's normally on a data sheet, that specification? I know it wasn't part of your talk.
No, it will depend. So some devices, particularly newer ones, if you go to the back of the data sheet, there will be a thermal profile for soldering, for instance.
Right.
So that's an upper temperature and a time limit that it's specified to withstand.
Right. Okay. So there's no rule of thumb where 3 times is. It depends on the component, probably, right?
Absolutely.
Different components have different tolerances.
Well, and even the component technology, right? So something with like nanometer track and space on it, and something that's like picometer track and space on it are going to have very, very different voltages and temperatures and currents that they can withstand. Right.
Right. Okay. Okay. Very good. Peter, you've got your hand up again.
Yeah, just something what you said, Eric, got me thinking a little bit. Is there I suppose one could say the biggest heat sink you've got in your junk box, just put it on that component and just live with it. But is there something that's a little bit more technically, in other words, is there kind of a rule of thumb where you can say, okay, if I need to we could probably all figure out how to dissipate a certain particular temperature and all that kind of stuff based on what the component specs are, blah, blah, blah. Does that give you a hint as to what physical size you would need to put of a heat sink on that thing? Now, I guess I suppose it's a bit of an unfair question, because heat sinks can come in all sizes and shapes, and some are probably more efficient at radiating heat than others. But is there kind of a rule of thumb of a physical size to dissipate X number of watts?
I really don't know. Not sure.
Another experiment rabbit hole to go down.
Well, it has to do with the surface area that the heatsink provides, and there's a formula for number of square meters of heatsink surface and the anticipated airflow over the top of that heatsink. That will give you a calculated degree C per watt.
Okay, thank you.
All right. Okay, that was great. Very interesting and concise presentation. So thank you very much, Charlie, for that. I think we all picked up a few things there. So Hassan maybe has a new new application for his nifty little thermal camera that he brought up to the cottage. So, oh, yes,
Oh, this
Hassan?
was no, this was a wonderful presentation.
Yeah.
We do this stuff at work, and this is really educational for me. I like the way you presented it. It was all correct.
Yeah. All right.
What are you saying? Some of my presentations aren't correct?
No, well, he, he was so concise that there was no room to disagree. Oh, well, I mean, obviously, the more debate there is, the more fun it is. So.
All right. So on that note, Peter, I have a question. Do you have a part 2 of your PLL discussion to bring up to this evening?
No.
No, because the reason I asked is because your name's on tonight's spreadsheet. So
It is?
it is, yeah. Like I know you sent out a note saying the updated spreadsheets posted. So, oh, wait a second. Oh, maybe it's not. Oh, you know what? I'm sorry, my fault. I'm looking at the old version. So, never mind.
All
right.
The good thing about this group is we can't fire you because we actually need you.
And just dock my pay. So. All right. So yeah, so that is my mistake. Sorry. While you were absent from the start of the meeting, I thought maybe you had snuck something back onto the agenda, but nope. This is a prior version. So my apologies.
No, one day I would like to do a part 2 on the PLL, but that'll probably be. There's a couple other projects, as we all know, that are on the benches right now that are taking all that kind of time.
Okay, so I think next we're going to maybe do a little bit of a show and tell, because we had our little mini build this past Sunday, and I am going to share my little photo album. It was shared just with the permission of the attendees. Speak now or forever hold your peace, because I am going to share some photos of the work that we did there, and those that want to remain anonymous can.
I'm going to leave now.
Is that coming up? Yes, no? Anybody see anything? It's just slow, that's all. All right. So there we go. I don't know how well videos come across on the sharing from
That's
a
the
photo
one.
album,
I mean, we can always whatever.
Probably not very well.
That's the one. I mean, we can always have a build-a-thon, whatever.
Very, very choppy. So let's just skip over the videos, because they're not going to translate very well. But and this is completely unedited, as you can tell, because we have bits of wrappers. But anyway, so yeah, it was Hassan, Michael, and I was the chief videographer for this event. Oh, that's a video as well. Okay. So many videos. So yeah, we're working on some of the prototype boards for the RF probe project, putting some of the surface mount components on. Hassan and Michael were. So getting a little bit proficient with that. I think there were some lessons learned about techniques, and I don't know if perhaps you two want to discuss some of the things that you know, your learns and your experiences with doing that. But I'm just trying to get a good shot here. I think that wow, lots of videos here. I didn't realize I took quite so many videos, but anyway, populated just a portion of the board. It was sorry, what part of the board were you guys working on?
That's the BF998, the input stage.
Right. So the plan was just to do that and then test it. But I don't think we quite got that far. We were just, it was really more of a soldering session than anything else.
I sure didn't get that far. We won't go there.
I believe
The
that was
idea was the idea was to do the first half, test it on the SA, then do the second half, and then test that alone, and then join the two together and test both. And hopefully, once we've done that, the results will be spot on with Dave's simulations. Hopefully.
And David also sent along one of his completed
Oh
populated.
yes, that's
Did he
right.
not?
I've got Dave's board here in front of me, and the discussion at the beginning was Dave had used pin headers as the input and the output, and I have some SMA connectors now. And what I did, I took his pin headers off, the input and output, and put on the SMA connectors, and hopefully grounded them properly and whatnot. So that's sort of what I've been doing. But this is Dave's board. What we're going to do, presuming everything's okay, with the soldering, I'm going to check it with the spectrum analyzer and the signal generator and see if I can produce Dave's results as well, is the idea.
So we did have Hassan's camera there, which we were using to look at the temperature of the heat gun that we were using to melt the solder paste onto the board with the components on it, just keeping an eye on what temperatures we were achieving. And I think it was off the scale that we had initially, changed the scale, and I'm not sure if we had any pictures of that. It was kind of hard to be doing all that once, but I believe it was getting to
maybe the thing to do is just
up in the 200s, I believe. So anyway, that was we're just out of curiosity than anything else. Peter.
Yeah, I'd like to. I know Howard and now Hassan and Michael have used the heat gun to soldering, and he's using solder paste and to solder the components onto the board using the heat gun. I'm still leaning towards a solder oven, but I just thought, since we're all gathered here now, that those, maybe those guys might make a comment about their methodology of using a heat gun and to put the components onto the board. And if anybody here has used a solder oven, I mean, I used a solder oven a million years ago, but and I liked it. At least that's what I remember. But anyway, I just wanted to comment from the guys here that are using heat guns as to, what do they think about their experience on doing it?
And if I could just jump in, particularly interested if anyone has experience using a hot plate, because to me that makes a lot of sense for this type of work, small boards, small areas, and then you're not dealing with the airflow, possibly knocking components temporarily out of place. So Howard, some input, please.
Well, I found, now that just might be me, but in terms of the hot air gun, I find that it works really well for ICs, but what I do for resistors and capacitors is I don't use it for that because I find it's really hard to get the airflow and the angle correct so it doesn't blow around. So what I have done, and I don't have a lot of it, this is my only experience with it, is I put a blob of solder on one pad and then just without the component there. And then I get the component ready to slide across the other pad and heat up the pad with the blob of solder and slide the component into the pad that already has the solder. And then once that's secure, then I solder the other side or the other pad.
I presume you're using just wire solder, not paste?
That's right. Yeah. So sorry. I just use a regular soldering iron. And so with a regular soldering iron and solder, I just put a blob on the one pad.
Okay, so then Howard, you're using the hot gun for ICs, but you're using the hand method for resistors and caps.
Yeah, I find I don't know, just the size of the ICs are a little bigger, I guess, and just all the different the way it sits on the pad maybe holds it a little better. But I've had really good luck with that, but not as much luck with the components.
Okay. Yeah, interesting. Dave seems to agree with you. He just gave a thumbs up to your method there, Howard.
So how did Michael and Hassan find things then? Because I think that you were putting all the components on then the heat gun.
Well, I let Hassan talk to that because he got all his components on pretty well in one go, didn't you, Hassan?
Yeah, well, all the resistors and capacitors, I think most of them. So I put the solder paste on. I think the having the right size nozzles is really helps. So and you have to have the right rhythm and get the right amount of paste. That makes it easier. The heat gun, I was afraid it was going to blow stuff off, but it wasn't too bad. But again, you choose the right nozzle and the angle at which the air comes, and it becomes easier. Um, the thermal camera really helps because you have to heat it up for like almost a minute, and I'm not very patient about that. And some people heat the board evenly and stuff, but no, I just did one at a time. And so I mean, there is a lot of waiting, patience, and it's a bit stressful because you don't know if you're like cooking the thing or what. But what happens is you put the heat on, and then the solder at first it looks like nothing's happening, and then all of a sudden you start to see the solder paste turn silver. As it melts, it flows, turns from a paste into a solid ball. The flux boils off and it's a solid ball, continuous surface, and then it becomes shiny. That's the cue that you're getting close. And then it's just a few more seconds, and then it gets soft, and the component kind of just falls into place. And then you move to the other side of the component, and it's a few more seconds, and it's done. And then I think you give it a few more seconds to kind of settle in, and just even out. And then you're on to the next one. So being a little bit impatient, I prefer that method, one at a time. Gives me time to fix mistakes. A solder oven is more precise, but that's only if you're doing mass manufacturing. If you're doing a one-off board, the heat gun's fine. And bigger components are going to be a challenge because they conduct heat away. So like I didn't do the things yet, the SMA connectors, the coax connectors. So that's going to be harder, but you have to be more precise with that. So a chisel tip or something like that would be really helpful. So overall, it was far less difficult than I imagined. It was
I think,
actually,
Hassan, like you mentioned the SMA connectors and things like that. I think those need to be hand soldered. I wouldn't put them in the gun or oven. But okay, well, thanks for that insight for me.
oh, but one more insight. On YouTube, some guy did it with a laser, and it was pretty amazing. And if you had like a 10-watt laser or a 50-watt laser from AliExpress in a 3D printer, that might be very interesting. You just place your board down and let this thing heat it up. And if you can't afford a laser, you can always get a magnifying glass and use the sun. So if I'm ever stuck on a desert island and I have to build a radio to call for help, that's what I'm going to do.
So Hassan, did you did, I thought you had put all the components on and then soldered them all in one go, but in fact you didn't. You did them more or less one at a time.
Yeah, I just applied the heat gun one at a time, but I did place them
Yeah.
all first together. With yours, Michael, we did them one at a time, right? And it was, I mean,
Well, it didn't really work for me. I'm not quite sure why. I don't know whether I'm looking at some of these pictures and I'm seeing the blobs of solder and I'm thinking the paste. And I'm thinking, boy, that's roughly what I did, I thought. But I obviously didn't heat them properly, and they sort of smeared all over the place. I've ended up taking most of the stuff off and I'm going to start over. But I'm going to try. I have a practice board first that I'm going to try and see what I can do.
I think what I've seen on YouTube or TikTok is people drench these things in tons of solder, like flux. So that can never hurt. The thing is that the flux is part of the solder and it boils off when you heat it. But if you if you wait, like if you do it for too long, the flux is gone, and then it's a harder problem. And I think in your case, what I've noticed is I was looking from the side. It's very hard to, I mean, see where your solder air is pointed. So
Mhm.
you have to have the right stance, and I think it's just a question of figuring out the right, motion and stuff, and then it becomes easier.
Well, I'm going to try. I've got this practice board. I'm going to try a few components on that again before I go and actually do anything on the amplifier board. And I agree with the comment about the, as far as putting the SMA connectors on, I'm going to do that with a soldering iron. I'm not going to try to do it with the heat gun. That's
Can you
my
use a
thought.
solder? Yeah, can you use a soldering iron with solder paste?
I don't know. I didn't do that today.
Certainly you can.
Yeah, I do it all the time.
Well, I have to say I have a Weller soldering iron, and it's got a Celsius versus Fahrenheit temperature, and I've always used it in Fahrenheit. So today I tried converting it to Celsius, and it appeared to only go up to 46.5 degrees because it was a little decimal point between the 6 and the 5. And it was only today that I realized that was actually not a decimal point. It was the marker telling me that it was Celsius. So, you live and learn.
Ken, you had your hand up.
Yeah, just how many boards were you guys working on? I think in one floor there was like 3.
No, it's only 2. Mine and a sense, actually.
No, like they're all joined together.
Oh, that's because Dave, this is the prototype board, and the top of the board that we're working on with all the components, that's the one with the BF998 and the 2SC 3357. That's the board we're actually building that actually works. The other one in the middle is where you can see on the picture. That's another that's an op-amp design, which we're not doing because the other one works. And at the bottom, the little one at the bottom, that's a test jig that Dave has cleverly arranged, that you put a connector in the thing with the 4 holes, vertical connector, and you use that as your probe, and the input comes through the other way and on the sides, and there's all the places to put resistors, so you can check out how good it is, how good the probe is in the sense of what is it telling you about the circuit you've got, because you've got known components, so you know what the impedance should be, and it's going to tell you by using it properly how good your design is.
Okay, good. All right, thanks.
Yeah.
Okay. Al, you had your hand up, but you took it down. Your question answered.
Actually, I was just going to mention to Peter, I've been using the reflow oven with good success, one of these Chinese ones. The biggest problem I had, well, it was 2 things. I had to calibrate it, so I had to install a thermocouple and compare it to the internal thermocouple on the device. So it was a little low in temperature, but the biggest lesson I learned was don't put too much solder paste on the pads. I was using a syringe to put the solder paste on, and when I heated it up the first time, they all floated away off of the pads. So be a little stingy with the solder.
I'll just reply back to that one. I'm leaning towards a solder oven. They're cheap enough now that, I just don't buy a bottle of whiskey this month, and then we'll pay for it. But when you think about, when you take a stencil and then you take the spatula and you put over, with the solder paste over the stencil, there's hardly any solder, because the stencils are only, I don't know what the actual measurement, but they're very thin. So there's not a whole lot of solder paste that goes on the pads, and they work great. So putting a globule amount of solder with your syringe on there is not necessary when you think about if you had a stencil, right? And speaking of stencils, I think is a fairly expensive option when you put it on the JLC PCBs and sites and stuff like that. So we're back to hand with the solder paste. But I didn't realize you had a solder oven there. All that. Okay, that's good. And you know what? There's that other solder oven that's floating around. So if somebody who's willing to try it, I guess it's up with Simon. I'm not sure where the solder oven is, but anybody,
I've got it.
you got it. Oh, give it a go then and see what happens. Okay, thanks, Al.
Peter, Pam probably wouldn't mind if you off hours use the kitchen toaster oven.
I will make a quick comment there. I took her baking rolling pin and used that for cracking grains for some beer I was making.
Right.
You want to know how well that went over when she saw all those little dents in her rolling pin?
She really.
Well, I got a dent in the back of my head from that rolling pin.
Really? That because she had too many of your brews afterwards and she was a little disoriented, maybe? I don't know. Anyway, well, okay. Hey, you know what? If first you don't succeed, try again. Isn't that the phrase? So, as long as you let it air out, there's just a little, like, why does my toast smell like flux? You can just say, you'll get used to it. It's an acquired taste.
Soak the wooden rolling pin in water and it expands and the dents aren't so strong.
Yeah. All right. Dave, you have been patiently waiting in the background there. What?
Yeah, I just wanted to mention, I'm with Howard. I've got a reflow station, and I only use it to remove parts. That board you're showing that I assembled that within I don't know, an hour, using a soldering iron, just the way that Howard described. I did that within about an hour, and there was one part that was the 806 part. The majority of them was 1206. The transistors were pretty small. There was one that's a SOT something or other, and I had no problems at all soldering those with just a soldering iron and regular solder. So it works, and I don't know what can I say.
Dave, do you happen to know what temperature your soldering iron's going at?
Let me turn it on and I'll tell you. I just turned it on. Let me see what temperature it goes to. I think it's about something.
The question will be, though, what solder are you using? Like you can get different eutectics, right?
Mine's set at around 77 Celsius, but whether that's what's actually on the tip, I don't know.
Se 77 Celsius, you said.
That's what the dial says. I don't know what's on the tip.
Mm-hmm.
Right now it's set to 390 degrees.
But this is a metric country. Put that in Celsius.
That's got to be Fahrenheit. The solder I'm using is just regular. I don't know. This is solder I picked up down at I don't know, Sale or the Boneyard. It's just regular, whatever, 80, 60, whatever solder, but it's very fine. This is really fine solder.
So about 390 Fahrenheit, roughly. Something like that.
Yeah, right now. And I think I cranked it up. I think normally it's a little bit lower than that. I cranked it up, I think, because I was soldering a part on a large trace. There was a fairly significant trace, and there was a lot of heat transfer needed. So I think I cranked up the temperature. I can't remember.
Because 390 would be around, 410 is 210 Celsius, so 390 is a bit below that. That's interesting. Okay.
Okay, Charles.
I just wanted to say that I've done many boards around this level of complexity, with mostly passives, using a Canadian tire heat gun. Without the special reflow station or anything. You don't blow the parts off if you're careful to keep the airflow down. That is, keep moving and keep the correct distance away from the board. But Yeah, 100 components, let's call it 50 to 100 components, particularly the passives, no issue using this kind of technique, using the putting down the solder paste, pushing the parts into it, and then basically heating the whole board with the heat gun.
How far away is the heat? How far away is the heat gun from the board, roughly?
Well, I'll move back and forth. Let's say 3 to 4 inches, that kind of distance.
Oh wow, okay. Because I was a lot closer, but yeah, okay, fair enough. Gonna have to experiment.
I noticed actually my 2 cents on your solder paste, Michael, is that it seemed to be a little runnier than I've seen before. Like it seemed wetter, maybe not as thick, as thinner, I guess. That's probably the word I'm looking for. So I'm not sure if there are differences when it comes to solder paste as far as viscosities or whatever you want to call it. But and also, I mean, as sort of shown on the picture that I'm sharing right now, there's a that's probably more like too much on each pad, right? So that was, I think, contributing to some of the difficulty with them floating around. So to Peter's point, the thin skein that you put on a when you're using a solder mask kind of demonstrates that. So, but it looked kind of hard to modulate how much you were putting out with that syringe. So that was my question is, like, are there different thicknesses that you could perhaps, expel more judiciously?
Well, I'm going to try again. This is the first time that I really used it at all, and I just went and bought the Chip Quick stuff from Sayal, and they only had the one type there, and I just bought it. So comes in a 15-gram container.
Have Fan used the same syringe?
Yeah, same, exactly the same. Yep. He was just lucky his worked. Mine didn't. Not sure why. I'm going to try again, and maybe just do a few components at a time, and keep the heater away a bit higher than I was, and just do a few at a time like Hassan did, and it should work.
Ken, please go ahead.
I've got the oven, guys. So if you ever need it, just give me a holler and I'll hand it over.
Interesting.
Okay, Ken, should I meet you where? Port Hope or Belleville?
51 Atkins Circle in Brampton. Front steps. No. If you guys have another get together and you want to try it out, just let me know. I picked it up from Simon. I don't know, 2 or 3 weeks before Christmas.
Hey, maybe we could try it all out the next 4 days at Eric's cottage.
Possibly, yeah.
Or take it down to FDIM.
They'll charge you a tariff on it.
By the way, Hassan, I've ordered a couple of the diodes, or some of the diodes.
I saw I'll pick them up from you, and then I can install them.
Okay, sure. Sometime, yeah. Okay. We pick a day and maybe we can try this board out again and see what happens.
Yeah. Nobody mentioned anything about hot plates, so I guess there's no experience with that. So that would be, I see that being used. So to me, that sounds like something to try as well. It's inexpensive. You can get them for as low as, I don't know, like $50. So Peter.
It'd be interesting to try for sure. I've only seen videos. I've never talked to anybody that's used the hot plate.
Right.
So, but you know what? It might be an interesting thing down at 4 Days in May to talk to the guys at Club Night. Have they what they're doing, right?
Yep.
Is it going to be in a buildathon in the future?
That's the plan, Michael.
Okay.
That's the plan. I think we've got a sort of a schedule that talks about, Dave, I think you're going to take it to FDIM, right? The completed board, a completed probe. Is that the idea?
We're far away from taking it anywhere.
Especially me.
Got 90 days. Plenty of time.
our original plan was to maybe have something ready to go for March, and then have it ready also for March, and then we take it to 4 days in May. Considering the complexities of this project, and I have no idea why this project has turned out to be so complex, but it is. So I think the real goal would be to take it to have it ready for 4 days in May, and then have the buildathon organized after that. That's my opinion.
Yeah.
You know what? Let's do it right. Let's not put an artificial timeline of getting it ready for buildathon in a month or two.
Oh, I agree. I agree with that.
And because I've not seen any of the YouTube videos or any of the other clubs homebrew stuff that I've seen out there. Nobody's making a probe like this. So I think it'd be quite, if we make it and do it right, and we present it at 4 days in May, I think we've got a winner in our hand and an excellent buildathon project. So
the question is which year?
Great.
You know what?
4 days in May this year.
For me, it goes back to COVID years. Back to Dave and Charlie, I got lots of advice from those guys, and it kept me going until finally I thought, and then we got around, and then we formed the team, and the team has been the best way to go with this project, where you can talk to everybody instead of getting, advice is great, but then you're left on your own to do it, and you're doing it, and it's not anyway. Whatever. Anyway, so that's the answer there, Cherry. Yeah, 1 day soon.
Certainly, getting together as a group worked for me. I thought that was good.
Okay. All right. I think that's enough on that topic. So we will move into the roundtable. Tell us what's on your mind, on your bench, on the horizon for you, whatever it may be. So, Al, you're the first on my screen here. What's going on?
Oh, I'm pretty much empty-handed. Don't have a lot on the bench, like I mentioned last time. I'm still recovering from floods earlier in the year, so the shack and the lab are not operational right now. So working on restoration. So it's all a dream right now.
All right, fair enough. You should be activating some parks. There's no shack required.
True.
It's a little cold, but beyond that. So anyway, okay, fair enough. You got your hands full with ancillary projects, which are kind of helpful going forward. So fair enough. All right, Charlie.
I've had a whole host of family things occupying me for the past month or so, so I haven't made a whole lot of progress on projects. I've got a couple of all-star units I'm putting together for 2 different clubs that seem to be coming together, and I'm still working on a Raspberry Pi version of SIGGEN written in Python, and I've got most of the blocks of it kind of working at this point, but I haven't got it all glued together by any stretch of the imagination yet. So that's what I hope to get done in the next perhaps month or so.
Oh, okay, nice. All right, Dave, how's your Z80 looking?
No, it's coming along. All I've been doing the past little while is hunting for a field for my rocket club. So my rocket club is going to start back up. We've got our insurance in place. We found a field, so we're going to go forward to Transport Canada to get it approved. So that's kind of what I've been working on.
All right, that's good. Hassan, how about yourself?
Yeah, by the way, Eric, don't you have a field you could lend to Dave?
For now, yeah, that's true. But, Dave hasn't asked yet, so I'm kind of waiting.
Okay. All right.
Transport Canada wouldn't approve that field. They wouldn't approve that field because there's no VE operating out of that field.
Hey, what about that little island across from the 4 days at Eric's cottage site?
Yeah, lots of you know, water around there for you know, putting out fires. Sure. All right.
Yeah. Then on my plate,
Yep.
nothing except my list of projects has been piling up, but I'm making some progress. So 3D printer, printing storage. If you guys have storage issues, check out Gridfinity.
Yep.
People love it. And I've been printing out containers, like dozens of them. Now every screw, everything has its own container, and it's a joy to behold. So I'm gonna finish that up. Um, Soldering. Oh, I've been playing with ESP8266s. They're amazing. They're super cheap. Um, their Wi-Fi works pretty well once you get it right, and that's gonna open up a whole lot of doors in terms of what I can do with projects. So go ahead, Dave.
Hassan, did you say 8266?
Yes.
Yeah.
Hassan, you know
Yep.
that processor is probably like 10 years old. It's been replaced with
By
like
what?
The ESP32, man.
yeah.
Oh, but your processor, Dave, is about 100 years old.
Yeah, exactly. 8266 is 160 megahertz,
You're
like
only
10
1
times
second behind
faster.
on average.
Okay, so
Yeah,
guys,
Ian explained to him what the like that's like a decade
ESP32.
old.
okay, I know there's a better one out there, but I'm trying to use up my old stock of boards that I bought 6 years ago. So that's my excuse. So yeah, I understand, but I'm trying to clear out my old parts. I bought like a bunch of these D1 minis, like 5 of them, and I want to use them up. So, but if you, Dave, if you have a recommendation for what I should use, and Ian, go ahead and tell me. I'll happily buy whatever you recommend.
You know what Dave's going to say? A Z80.
That's 50 years old.
Yep.
I forget what they call this thing.
All right, Ian, you're up anyway. So.
Oh, okay. So it's the ESP32 Dev Kit V1. Search that on Amazon. You can get them or anywhere. So yeah, big lots of progress on continuing work on my diagnostic equipment for this streetcar thing. So speaking of ESPs, so I've employed ESP32s. So I got to rate in 20 something or 20 analog values and 30 something digitals. So I've got I2C DACs or ADCs, 5 of them, and then I got 2 IO expanders. And then this board is just sending simulated data. And then I've got it where it streams wirelessly and I can get it all on a web page with nice gauges. And I don't know, let's see if I can I share this tab? So I don't know if you guys can see that.
Yeah, we can see it. Looks cool.
Yeah, so that's pulling live data off the ESP32. And it can go pretty quick. So I got the proof of concept now. I got to figure out one problem with because I figured out my scaling thing for the analog. I don't know how I'm going to make it fit in the circuit board because it's all it's a voltage divider into a adding op amp, and then I add a volt in to shift the negatives up into 0 to 2.
Well, to make it fit, you can't use 1206. You're going to have to go to 604.
Because I need like 20 of them, and then the board's got to be yay big to fit on the connector. But let's see, can I share that screen? Yeah, so that's the contraption I came up with for scaling the plus and minus 15 volt signals down to 0 to 2 that the ADCs can read. So
how'd you solve that problem? You were asking last time.
Yeah, this is the circuit I came up with. It should be on this sharing. So voltage divider, divide by 16. these are clipping diodes, so if it goes over or plus 15 or under minus 15, it won't. It'll just clip it off with a zener. And then 1 volt reference, and then just an op amp to give it enough current. Gets summed in to this op amp, which is just unity gain, and then you get 0 to 2 volts out. And then I can feed that into the ADC that the ESP will read, and then it shows up on the gauges on the web page. But that's a lot of components to fit on the circuit board with 2 op amps times 20. So 40 op amps and then all these resistors. Not sure how I'm going to get that all fit. That's a challenge for the upcoming. And then my current challenge is for the digital signals, because it's 15 volt high. So I was using level shifters, but the PCF, whatever, 8575 IO expander does some weird like pull up on well, it's like a really hard pull down on when you're using it as an input. So the level shifters can't really register 0 properly. Because I need to have a known 0 when it's floating, so I need them pulled down. That's a new challenge to figure out. If I run it like directly off the ESP, it works fine, but with the level shifter, it doesn't. When I'm at 0, it'll only go to like 1 volt, which isn't enough to trigger it when it's floating. Anyway, that'll be the next adventure. It's getting closer though. Lots of 3D printing though. I've been printing cases, so I need the error display. So that's the display out of the car, and then the reset button. So I just printed this box up for it. And I'm printing storage. The 3D printer is going on next to me, printing up storage as well. Lots of CAD design and fusion and whatnot.
Okay. All right. Thanks for sharing that. Ian, the project continues. So.
Yeah, going to be going for a while.
For you.
Sure.
Yeah.
Yes, and level shifters are those. Is that, are you referring to your analog circuit, or are you referring to like a digital level shifter?
Digital. I just need to convert the 15 to 3.3. So it's just using, like this one's just like a basic like transistor one that I'm using.
Mm-hmm.
But it's the IO expander board. The way it does the pull-ups, I think, it's weird when you're using it as an input. The output is fine. The only way you can get it to go to 0 is if you like hard short it to ground. I don't know, like a 1K pull down didn't do it.
Well, you want floating plus or minus inputs, 15 volt different. So you want differential inputs, or you should use an optimum.
No, I just need. That's what I'm looking at now. Like when you fire this IO expander up, like it defaults all the pins to high. It makes it look like everything's on. And I want them to default to low, and then only go high when I have an actual signal. Which is all right if it's there, but if there's like a broken wire, it'll look like it's high all the time.
Okay. Okay. So another question is you have 40 op amps or 80 op amps on your thing. Have you thought about using an analog mux if you don't need to scan them fast? Just put an analog mux.
I need to scan them fast. That's why.
How fast?
Pretty fast.
So,
I'm doing like 100 microsecond right now. I need to read live data off the car.
So that's 10 kilohertz. So the ST Micro ADC can go up to 3 to 6 megahertz. So if you put a 14-to-1 mux there, I mean, it'll just keep reading, but you're just sweeping the signals. You should be able to get 100 kilohertz out of it.
Am I looking to? Because I have some muxes here somewhere.
Yeah.
Let's see if it's fast enough.
Yeah, because inside the microcontroller, there's already a mux. That's how you get like 10 ADC pins. they're all muxed into one ADC, and the rate goes down. But just put the mux on the outside, and now you have less analog circuitry to worry about.
Yeah. I might have to do that because that's going to take up a lot of room. If I can get away with like 1 or 2 of those scalars, that would take up a lot of space.
Mm-hmm.
There you go. Dave had something for you, I think. Ian?
All right, go for it, Dave.
Yeah, Ian, have you done any searches on DigiKey? Because I had to get some level shifters, and they've got them where they can go from almost anything to anything digital, which is what you're looking for. You're not looking for anything analog, and they've got them, and they're not that much on DigiKey. The pin count is not high. Typically, it's like 8. I don't think I've seen any 16. It sounds if you need a high pin count, but some of these things are like SMT, or you could. I think they have through hole as well. So
yeah, I've got room on the digital board, so I'm not. So like right now, it's all discrete like transistors I'm using. So
yeah,
2 chips would be fine on the digital board. You got to think that a lot of them won't take 15 volts in.
Yeah, some of them I can't remember. Some of them have a pretty wide voltage swing, but I think maybe 12 volts, because I think like RS-232 goes up to
a lot
what?
of them go to 12, but they won't go to 15.
So Mike, maybe right that 15 may be unachievable.
Yeah, I'm starting to look at opto isolators too. They're not cheap though. They're like $14 each. 4-channel.
Yeah, for like a opto isolator.
Yeah,
how would you use that though? You know, Ian, we're probably taking up a lot of time here.
Yeah.
But
I don't need bidirectional, so I only need the input. So.
Okay, so then once you get the old cheapo, because I got a whole stack of them here. I got a Dayton, like I got a whole reel of them, and I paid next to nothing for these things. And you get the dip ones, right? The large, and they're pretty inexpensive. They're just going to take up a lot of real estate.
Yeah, real estate's what I don't have. It's got to fit on a connector about yay big. So I'm trying to make it so that there'll be a digital level, the analog level, and the microcontroller level. And then it'll just plug into the jack on the front. And that way it'll fit, and it can just live there on the car permanently. Yeah.
Ian, remember, voltage is just a number. If you put a 1 mega ohm resistor in series with it, you can feed it into anything safely.
Yeah. Well, the other thing, I also kind of want to buffer it on the input because I don't want it to affect the circuitry in there.
Yeah, so 1 mega ohm will buffer it too, or isolate it at least.
Yeah. So I'll give that a go. This month has kind of been getting the ESP32 and see if I could get the data fast enough onto a web page. So I've got that down now. And I've got like the proof of concept. So now I'm getting more into how do I shrinkify. So I'm going to look into those kind of ideas. So those are some good ideas for me to play with.
Okay, thanks for sharing all that, Ian. So we're going to move along here just so we can have a bit of a discussion on AI and all of that at the end with any of those who have things to contribute. So just so we don't leave those out that might have something to say, what's going on? Cherry, anything on your end there?
Yeah, I've been very busy at work. So I've been doing some reading actually, and I just wanted to show what I'm on right now. Like, I'm now a member of this GQRP club, which is absolutely having a lot of good magazines from them called Sprat. I've been getting them last year and this year beginning. So I find these are pretty good, much better compared to QST or something else. They have some, antenna handbook and some other magazines which they had some previous you know, projects being printed together. I find these to be excellent, like this GQRP antenna handbook. These are like excellent articles, you know, written from homebrew experiences. Yeah, and I just wanted to share it here. I know maybe a couple of you are already members, but this is really great. Yeah, and I just love it. You know, doing a lot of reading with this, and I find it very, very interesting. Not a lot of I mean, actually no advertisements, and all the material is pretty interesting to read. These are from the GQRP Club, and I find it really interesting. I've been a member since last year, and planning to continue that this year as well. So
yeah, they used to be down at Hamvention, but I don't believe they've been there post-COVID. No. So yeah, but they used to have a table. So
really, they yep. used to come to Hamvention.
Yep.
Okay. Did. So the only problem with these magazines or you know these books, if you order them, it's a little bit expensive for the postage. For example, I think I paid double the cost of this book for the postage. So the membership is very cheap. Like it's $30, and you'll get 4 magazines every year.
Right.
But these are very, very interesting. Like, you know, if you're not reading this, you're missing a lot of things. That's what I would say. I think Peter is a member, but I find this very interesting. And yeah, you are too, Al. Okay. So I find this very interesting. And, you know, I'm thinking now, why didn't I subscribe this before? It's $30 to $32 a year based on the pound variations. I think it is 16 pounds or something. So we pay, or PayPal, it's $32 or something, which I paid this year, you know, a couple of weeks earlier. So if you're not a member, I think, yeah, you will not get these magazines. These magazines are really, really cool. These contain small projects. It's very, very interesting to read. In fact, it's only a magazine with a few pages, but yeah. I've been keeping on reading it because it's very, very interesting. Yeah.
And if you like that, they also offer all of their back issues on a DVD that you can buy, right? So
exactly. I'm going to definitely get that. It's just a really matter of time. I'm going to get that. Yeah. So I really love this, and yeah, I would like to suggest this one. For example, this antenna handbook itself is very, very interesting. These are coming with like, you know, notes written in the past, but definitely this is something very interesting to read and also like to experiment. Yeah, so yeah, I find myself keep reading it like every day when I go to bed. Like, you know, I have one of this magazine near my bed to read, and I find it very, very interesting. So I just want to share that. Thank you.
Okay, thanks, Jerry. All right, so maybe just in the interest of time, let's. Did anyone else have anything? If they do, then we'll let you jump in. But who's got some experience with? You know, I know there's been some talk on the SOAREX groups.io with regards to playing around with AI, and we had a brief discussion at the beginning. Some of you have loaded DeepSeek onto your own personal equipment and played around with that to a certain extent. And so who's got some, you know, experience doing that, and or some thoughts on the current news cycle? Peter, go ahead.
Okay, I've not tried the DeepSeek, but I have been playing around a bit with ChatGPT. Now, a couple of years ago when I first tried that, I found it very helpful with one of the presentations that I was doing. It did help that I knew, at least I think I knew, the topic that it was at hand. So when I was looking to clarify a few of the finer points and I wasn't getting out of the various books that I have on hand, it helped me out with that. In fact, it helped me out so much I even rewrote a portion of my presentation. Since then, of more recent note, I've had it help me with some LT Spice directives. Now, the problem there was I wasn't asking it the right question. So it was giving me answers based on what I was saying. And as I was going through the process, I realized I'm not really asking it the right thing. And once you get a handle on that, the answers became a little were better. Having said that, it wasn't a waste of time either, because the answers that I was getting, even though they weren't correct for what I was looking for, they gave me ideas somewhere else. Now, another thing that happened was one rabbit hole. I can't even remember what the rabbit hole was, but it was a mathematical question with something that we've been doing with our stuff here, and it said, "Would you like me to write you a Python script to help you with your calculations?" Oh, I know what it was. It was phase noise, and I said, "Sure, why not?" And so it gave me this, and I'll do a presentation in the future on this, and it was perfect. The Python script was absolutely perfect. There was other people, my Saturday morning breakfast with the Carix group, a couple of the guys in there are heavily into Python, and they've made comments where ChatGPT was perfect with the Python script. So I found a very positive experience. But the other one, that I don't know. That's about it for me. Thanks.
Okay. Kevin, I know you were playing around with that DeepSeek, and you had some interesting information with regards to the, what was it like? It was off by a factor of 2, over 2 from your calculation?
That was just a calculation that I asked Copilot to do, because Microsoft has
right.
Copilot.
Right.
Bundled with their Microsoft. Well, now, in fact, they don't even call it Office anymore. It's my Copilot for Office or something. And I believe that runs on the OpenAI sort of Chat GPT back end on that. But I mean, it pulled up some, I asked it an engineering question with a whole paragraph for a prompt, and it got all the right equations, but it didn't do the math right. And it's like, that's, to me, was kind of concerning. I'd understand more if it got the equations wrong, but it understood the equations and put the right numbers in the equations, but the actual number that it calculated was wrong, which I do not understand. But anyway, I don't know. I just, was playing around with it and running, putting prompts into DeepSeek and Llama 3.2, I think I was running, but the smallest models, so pretty restricted, right? So.
And what were you running it on again? Was just
I have an old Dell engineering laptop. It's got a 2 gig GPU in it.
Okay.
So it could put all the parameters in GPU memory. But I'm actually taking my son's old gaming PC that has a 6 gig NVIDIA GPU card with, I don't know, like several thousand CUDA cores or whatever. So then I can take the bigger model and put it in there. So then I'm going to play with the bigger models and see what's happening. So just for fun, because I have a little project in mind, actually. So I kind of want to see how well these, local models work.
Right.
One of my first techie projects when I retire. So
okay.
We'll see what happens. I don't know. It's interesting, but at the same time, I'm very wary of them hallucinating.
Yeah, that's probably one of the best ways of testing it out is a subject topic, like you said, calculations in your case, something that the correct answer to, and just testing it that way. So that's probably at this point the best way of assessing these various models and how well they work. But again, to me, like I said in my posts, I know Dave was saying he thought I was just trolling, but honestly, these things are impressive, but I don't think we're at an inflection point myself here. I think this is still just looks complex to us, but they're just fast number crunchers essentially, right? So Hassan.
Yeah, I tried out DeepSeek the other day. I saw a YouTube video, get it installed in 2 minutes. And, it took me a couple. I mean, the simplest model did actually install in like 5 minutes or a couple of minutes. And then I tried to install this web interface, which basically lets you run something that looks just like ChatGPT on your server, on your own home PC. It's just a web interface with a single search box. That took the whole night because I had to install Docker and, you know, free up disk space, yada, yada, yada. But when I got it running, I tried the smallest model, 1.5 billion, 7 billion, and then I tried 32 billion. And one of my friends said, ask it about the Battle of Varna. And, you know, the 7 billion model said, oh, it was fought between the French and the Germans, which was wrong. The 32 billion got it right. It was fought between the Ottomans and I think the Eastern Europeans. And then the 1.5 billion model thought it was between the Romans and Carthaginians. And I thought, were the Ottomans involved? I said, yeah, the Ottomans and the Romans were involved in that battle. Like, it basically reasoned because they're in the Mediterranean, they would have, you know. So the 1.5 billion model is about as good as a stoned high school student who didn't do his homework.
Yeah.
The 32 billion model is good enough for coding. And the 7 billion is in between, but overall it was really impressive.
Yeah. Okay.
Yeah,
Peter.
so, but this is amazing. Yeah.
Oh. Yeah. There you go.
Okay. What was I going to say? Oh, I did a poll the other day or the other week. I can't remember which. About who uses ChatGPT with our favorite subject, right? And I got 12 responses. 3, which included me, said yes. 7 said no, and the other choice was once or twice. There was 2. So I guess it's not surprising in some ways, but I do find that it's very helpful. As I mentioned earlier, it also helps that you know the subject somewhat, and you're just wanting to refine, you know, some of those little points. And I find it's really, really good for that. And and you know, I'm starting to go to ChatGPT as my first go-to instead of doing a Google. So anyway, all I can suggest is give it a try.
Yep. Well, it's like anything else. You have to take all the sources and then, you know, form your own opinion, right? In the end, I think that same thing still applies, right? Use but verify. So, yeah. Okay. Looks like we're getting a lot of people dropping off. So does anyone have anything else that they like to add that they're working on or anything that I haven't got? Or should we call it a night? Going once, going twice. All right. Well, I think that's a wrap. So good discussions, gentlemen. Thank you very much for a good evening, and yeah, we'll see you on the 19th, I believe it is. Yep, 19th of February. Got a regular meeting coming up with a presentation by Wayne, so who I don't think joined us tonight, as far as I know.
Yeah, he was there, but he dropped off a little while ago.
Oh, he did. Okay.
Half hour.
All right. Okay. Well, anyway, you take care, gentlemen. Be safe, and hopefully the tariffs don't bite you. So.
Good night. Thank you.
Cheers,
All right.
Cheers.